This video is about four things in maths that have the same meaning, and it can be a classic tricky question in an exam to give you one of the four meanings and expect you to switch to one of the other three. One of those four things is not quite this. This you should be familiar with as an instruction to do a reverse differentiation. The answer would be x to the power of 5 plus x squared plus c. That works because x to the power of 5 plus x squared plus c, when you differentiate it, becomes this. Now that you already know. In other words, a curly with the dx is an instruction to do a backwards differentiation question, which in some books you'll find called a primitive. That's not what I'm talking about. What I'm talking about is if there are little numbers here, actually I'll make that a 3 just to keep the numbers smaller. Now that is called a definite integral. When there are little numbers there, it's called a definite integral. Okay, now so that's one of the four things. Here is one of the other two. Instead of writing a curly with the dx, you have an alternative option. You can write squared brackets. And instead of that going on the curly, it goes on the top right, and instead of that going at the bottom of the curly, it goes at the bottom right. You don't need the dx, and you, instead of writing this, you write the primitive of it. In other words, what you would differentiate to get this. And you also don't need the plus c. So what I'm telling you is that these have the same meaning. To switch between them, you need to do some work. If you want to switch from this to this, you have to differentiate. If you want to switch from this to this, you have to integrate. Okay, so there are two of the four things. Here's the next thing. If instead of writing square brackets and instead of writing a curly, you don't want to do either of those, you can instead, and this takes more ink, you can instead write two great big brackets with a minus sign in between, and in each bracket you write this, but you do not write x. You instead write that in the first bracket and that in the second bracket. And there we go. So what I'm telling you is that these have the same meaning. So instead of writing it once with x's, you can write it twice with numbers. Just make sure that the first bracket has this number instead of the x, and the second bracket has this number instead of the x. So that is, they're your 3 out of your 4 things. Just before I tell you the fourth thing, I will give you another example. So here is 6x squared with a 2 and a 0. Let's actually make a 1 and a negative 1. Actually, okay, so I don't have to write the curly and the dx. I can instead write the primitive of that, which I think is 2x cubed. Yes, it is. And instead of writing these on the curly, I write them on the top right. And if I don't want to write the square brackets, I can write great big curly brackets twice. And you don't write letters, you write these expressions here. Okay, so there are your 3 meanings. First, second, third, first, second, third. Curly, square brackets, double brackets with a minus in between. Curly brackets, square brackets, double brackets with a minus in between. Okay, now here's the fourth meaning. The fourth meaning is the area you get if you drew a graph of that, or a graph of that, and worked out the area between it and the x-axis as far as this on the left and as far as that on the right, but also taking into account that areas underneath the x-axis need to be treated as negative. Okay, now what I mean by that is this. I'm just going to graph this one here. That is a basic bucket stretched by a factor of 6. So your fourth meaning is this area here. In other words, the area between the curve in the curly and the x-axis as far to the right as this number and as far to the left as this number. Okay. Now, about 45 seconds ago, I'm sure I confused you when I said that you had to treat some of the areas as being negative. What I mean by that is this. So I'll just show you the meanings for an extremely simple one like this. Okay, so that's your first meaning. Here's your second meaning. Here's your third meaning. I haven't left much room for my minus sign there. That's your third meaning. Okay, so your fourth meaning for this is the area between that graph and the x-axis as far as 2 to the right and as far as -1 to the left. And that's a very easy graph to draw. So your fourth meaning is this area here. Now, of course, you can actually work out what their area is. This is a triangle of base 2, height 2, so half the base times height is 2. This is a triangle of base 1, height 1, so half the base times height is half. But because this is below the x-axis, we write -half. So in other words, the fourth meaning of this is called the signed area. In other words, area where you have to take into account that some parts are negative. So the fourth meaning is clearly 1.5, because 2 plus -half is 1.5. And in fact, you can see that if you work that out, you get 1.5. So this checks out. Now, the area of this, I don't know. I can use areas of triangles here. Areas of this, I can't work that out directly with my year 7 knowledge, but it's okay, because the fourth meaning tells me that that area is this, and that's a 2, that's a -2, so the area of that shaded business is 4. Just give you another example. This is an example where I'm not actually going to tell you what the algebra is. Now you know how we avoid telling you the algebra for the rule. We just write y equals fx. So here's the graph. So it gets as high as 2, it gets as far to the left as -2, and it reaches out to 5 on the right. Now, so the mystery algebra for that graph is just fx. So I don't have any algebra, so I can just write fx, or y, and it goes as far to the right as 5 and as far to the left as -2. Okay, we also learnt that instead of the curly, we can write the primitive. I don't have a name for that, so I'm just going to write P for primitive there. And instead of those on the above the curly, I can write them to the right. We can also write double regular brackets instead of squared brackets, just as long as we write a 5 instead of x and a -2 instead of x as well. So they're your four. They're your three meanings. Now the fourth meaning is your signed area. Okay, now I realized that I made a mistake with this. I meant the graph to be down there. Okay, so your signed area is this. That area, which is clearly a square, a 2x2 square, so that's an area of 4. This area, which is a 3x2 rectangle, so that is an area of -6. And this is another 2x2 square, so that's an area of 4. So your fourth meaning is 4 plus 4 plus -6, which is 2. So even though you didn't know the algebra, you can still work out what these are, because they're all just four things for the same, expressions for the same thing. So if I asked you this, it would be a fair question, because you just switch to the area meaning and you say that it's 2. If I asked you this, it would be a fair question, because you switch from the curly meaning to the area meaning, and you get and you get 2. Now, this leads to questions which students famously get wrong because they think they need calculus to answer them, when in fact they don't. So that's why this video is partly called Area Without Calculus. Now, I'll give you an example of that. No Year 12 student has the knowledge necessary to do calculus on that. It's just not something that you have the techniques to do. Okay, so do not use this meaning. Do not use the second meaning, because that requires you to know the primitive of this, and I'm just saying you don't know that. Do not use the third meaning, because that requires you to know the primitive of that, and you just don't know that. Instead, switch to the fourth meaning. Graph this. That's a semicircle of radius 2, which goes as far out as 2, as high as 2, and as far to the left as -2. So your fourth meaning is just the area between that and the x-axis, and that is a circle of radius 2. So its area is 4 pi, but it's only half a circle, so the area of that is 2 pi. If I'd asked you this, that is now a semicircle underneath the x-axis, and we want the area as far to the left as 0 and as far to the right as 3. So that is a quarter circle. If it was a full circle, it would be pi squared, which would be 9 pi, but instead it's a quarter of that. And under the axis, you get -9 pi over 4. So this is an example where I ask you a question mentioning the first meaning, and then you forget the second meaning and the third meaning, and you switch straight to the fourth meaning. Now, of course, if you do know how to do the calculus, do the calculus. Don't worry about the area. So if I ask you this, just do your thing. Switch to the third meaning. I think that's right. Yeah, I've used the numbers instead of the x's, and this expression is the primitive of that, because if you differentiate a quarter x to the power 4, you get x cubed. Just work that out. So I think that's 4 to the power of 4 is 256, divided by 4 is 64. So that's 64 minus a quarter, which is 63 and 3/4.